Today I'd like to show a couple boards that I created, which do a pretty good job emulating the sound and functionality of the EMU SP-12 drum machine. A couple years back I started with a modern design, more of a recreation of the SP-12's analog circuitry, with the ADC filter, the 12-bit DAC, the 8-channel multiplex output, of course MIDI, and the custom filters, low-pass filters in the first 2 channels. And after a while I realized that it's not so much the sound of the SP that's critical to making good music. It's sort of the workflow. So after proving all the analog circuitry could be recreated with either the same or modern components, I moved into recreating the actual SP-12 digital operating system functionality. And for that, I recreated the Z80 portion of the machine, and I still have to add the audio portion and the audio pitch shifting and address generation, sampling components. But I just wanted to kind of show what I've done so far emulating the OS. So I have a small button board that try to make it as small as I could, representing all the buttons on the SP. And I'm going to go through a few of the tests that come on the SP debug EEPROM, so just to show you it working. So like for instance, there's a button test, and if I click these buttons, you can see the different buttons registering on the screen after you press them. Let's see what else. There's an LED test. And I can kind of scroll through, and you can see the LEDs lighting up as I scroll through, back and forth. No big deal there. There's various tests for testing the like the CTC and the SIO Zilog chips, which are critical components to this machine. So, for instance, this is the CTC check. You can see that you can read write. It responds to interrupts correctly. Here is the SIO test. I've got the MIDI connected in loopback, so we can actually test the MIDI test. That's a simple, oh no, that was the wrong test. That's the NVRAM test. You have to wait till that finishes before I exit out. Let's see. I believe that's 10, sorry. Try that MIDI test. MIDI, okay. There's a few other tests that I can't run yet because I don't have the hardware connected, or it's not part of this board. But that will be in another video. I've got some more boards coming in that extend the functionality of this. In fact, the next board removes all of this clocking circuitry and address decoding, and it replaces it all with a single FPGA. My initial tests actually were all in FPGA, so these circuits have been proven in FPGA first. The only real tricky part was the PAL decoding. So this chip here is a recreation of the SP-12 Turbo PAL, and I've recreated the equations for that PAL along with the other PAL in the microcontroller portion of the SP-12. So that'll all be in FPGA, and that'll definitely reduce the amount of parts on this board. And that's about it. I hope you liked it.